Hello, welcome to part two of division with exponents, and we have a second property to deal with here called raising a quotient to a power. So if you would just continue your notes, please, from where we left off in the last video. Write down the name of the property, raising a quotient to a power, and we'll see the rule in a minute, but let's go ahead and see what's happening here in our first example. You would get that copied down just like that. We have in parentheses, which is important that you have that parentheses right there. We have x over y, and then in parentheses the power of 3. So basically what we have the base is this. That is the base of the power. Okay, x over y. So we have x over y times x over y times x over y. We have three of them, 1, 2, 3, because of that power right there. Now we can see what we have now in our numerator. If I multiply that, x times x times x, it's simply x to the third over y to the third. And that's all we can do right there. We have positive exponents, and we got rid of the parentheses. That's what we need to do to simplify this. And that's your answer. Okay, so you can probably already see what's happening here, that everything within the parentheses, when you have an exponent on a parentheses, everything within the parentheses is taken to that power. X to the third, y to the third. Pretty simple, really, I think. Let's take a look at number 2 and see what happens there as we have some different powers here. Within the parentheses, we have a, now remember that's a to the 1 right there, times b squared over y to the fourth. Well, everything in here now is going to the power of 3. So a to the power of 3, all right, b squared to the power of 3, and y to the fourth to the power of 3. So real quick, here's basically what you have. You have ab squared over y to the fourth. Oh, not equals there. What am I doing there? We have another a b squared y to the fourth. We have another a b squared y to the fourth. Okay, so that's because, again, like we did in the last problem, that's your base, and everything is to the power of 3, like I started to say a moment ago. So notice what we have here. You have basically a times b squared times a times b squared times a times b squared. Now we could expand all this out because it's a times b times b times a times b times b times a times b times b, giving me a total of a to the third. Now, the b's, I have 2 b's, I have 2, so I have 6, b to the sixth, over y to the fourth, so I have 1, 2, 3, 4, 1, 2, 3, 4, I didn't finish my y to the fourth there, y to the fourth, y to the fourth, y to the fourth, 4, 8, 12, we have y to the 12th in your denominator. Now notice I have all positive exponents, I don't have any of the same bases sitting around there that I need to simplify, so that's the solution. So you might be noticing that, hey, we learned when we raise a power, like so take the b squared to the power of 3. Remember the property where we went through 2 times 3, which is 6, and it gives us this. 4 times 3 gives me that exponent right there. And that's basically the shortcut that we'll deal with. But the main thing you need to know is that to raise the quotient to a power, you have to raise everything in the numerator and everything in the denominator to that power, and then simplify it. Okay, so you look for positive exponents, see if you can apply, need to combine variables that have the same base. If you do all that, you should be in good shape. And here's the algebra property, and I'd like that to be in your notes as well. It's good for you to try to begin to see things algebraically and what they're trying to tell you, that's exactly what we just described right there. Okay, let's do a couple of examples real quick, and then we'll be done here. Alright, so here's your next problem. Copy down 3 and 4 there, and if you want to hit pause and try it, that'd be cool to try. If you want me to just explain it to you, just let the video keep playing. That's your choice. Here I have z to the 2/3 over 5 in parentheses to the power of 3. So using the rule from the previous slide, which I recopied here, I have basically, in the numerator, I have z. I'm going to put a little line through my z so you know that that's the z. You don't get confused with the 2. Z to the 2/3 times 3. So I'm going to multiply that over 5 to the power of 3. Okay, so if we just multiply this, if we recall our rules for multiplying, those 3's will cancel out because they're common factors, numerator and denominator. It's like multiplying times 1. You basically have z to the power of 2 over 5 to the third, which we need to multiply out. We need to simplify that. 5 times 5 times 5 is 125. And there's your answer there. Number 4, same type of question, but we have all variables here. The base is a over b to the power of negative n. So basically you have a to the negative n over b to the negative n. But you should be realizing that, hey, you can't do that. You can't leave that negative exponent. So that a is going to have to go to the bottom, but we also have a negative exponent there. So that one has to reciprocal and go to the top. So the final answer is b to the positive n over a to the positive n. Right there. And that takes care of that one. Let me show you one more of these, and then I'm going to do a scientific notation question, and that'll be the end of this. All right, this fifth example here is 2 to the negative 3. So we go 2 to the negative 3. All right, 6 times negative 3 there for the x, so you have x to the negative 6 times 3 is 18. And then you have 4 to the negative 3, so you have y, 4 times 3 is 12, but negative would make it negative 12. So we have that right there. So let's just finish simplifying that, and we've got a little bit of work to do here. That negative exponent has to change, that has to change, and that has, so all of the exponents are going to have to change. So basically everything is going to swap locations. Y to the 12, 2 to the negative 3, that would become 2 to the third, which is 8, and then x to the negative 18 would become x to the positive 18. Right there, and there we have it. All right, one more question I want to show you that you will see in the homework is some scientific notation that would be written like this. I actually copied the instructions out of the book, just like the ones you'll be doing for your homework, and one of the examples is kind of like this. So if you have this type of thing set up, what I'm going to do here is kind of like we did when we multiplied. I can actually just divide this part right here, and I can divide that right there, and here I can apply the rule I just taught you where we have the same base and we subtract the exponents, making that part much more simple. Than it's much easier than trying to multiply this out on your calculator, dividing it and turning it back. All we're doing here is 8.4 divided by 2, that's 4.2, times, now here you're just taking 10 to the negative 5 minus negative 8, and we're going to work that out. Change that to addition. Negative 5 plus 4 is positive 3. So we have 10 to the power of 3. Now I lucked out on that one. This is in scientific notation because remember that number must be between 1 and less than 10. Okay? Greater than or equal to 1 and less than 10. And it is. If it's not, you then have to either divide or multiply that number and then do the opposite to the 10 to hold its value. So hopefully that gets us through this section 7.4. Bring your questions to class and we will get rocking and rolling on it when I see you next.